Okay, welcome guys. Happy Friday. Um, this is Mr. Jensen. Please be kind to him. I want to hear nothing but glowing things and how fantastic you all are, because you guys really are. You're always really good to me, and I want you to be good to Mr. Jensen. Okay, why don't you guys go ahead and pause this and take about 5 minutes to get these answers figured out. You're going to need your notes from yesterday to take a look at how to find the horizontal asymptotes, because that we need a little bit to, we got to go back and probably refresh that. Okay, so horizontal asymptotes, figure out all of these, come back in 5 minutes, okay? So pause this. I'll see you in 5. Okay, time flies. So let's talk. How do I find my horizontal asymptotes? Remember, I looked at m, which was the degree in my numerator. The degree in my numerator is 2, and then I looked at the degree in my denominator. We called that n. So I've got 2, so m equals n, and there was that rule where I took the coefficients of the leading term, the one up here and the one over here, and I used a ratio. So y equals 1 is my horizontal asymptote. Okay? Easy peasy. Now I hope you factored. I hope you factored into x plus 7, x minus 5 over x plus 6, x minus 5. Okay? So that's factored. And a whole is where we cancel a factor. So I hope you remember that from yesterday. Where do we cancel a factor? At x minus 5. So there's a hole in my graph at x equals 5. And vertical asymptotes. How do we figure out the vertical asymptotes? We take a look at, after what's canceled, what's left over. At x plus 6 equals 0. So at x equals negative 6, I have a vertical asymptote. And my domain, if you remember from yesterday, my domain was all real numbers except the two things I can't have. I can't have a denominator of 0. Where does that happen? At negative 6 and at 5. So it's all real numbers. I can use any number on the planet except negative 6 and negative 5. Where did those come from? From the denominator. Okay? So when you were finding the restrictions last week, it's the same thing. You're just finding domain, okay? So when we apply it to the graph, we're talking about domain. All right, let's move on. Whoops, repeat slide. Okay, this is learning target 3. You guys are going to learn how to sketch the graph. So I want you to note that it's sketch. It's not going to be perfect. It's going to be a sketch, okay? We're not even going to use... I'll show you when we get there. All right. You should have your packet. And on the first page of your packets, we're going to do a couple problems with you. The rest of this is going to be homework. But the first page of your packet, problems 1 through 6, you need to do. And I'm going to show you how to do the first one. And maybe number 6. So what we're going to do is I want you to go ahead and I want you to highlight this number and this number. Anything that's outside of the fraction that we add or subtract, what these things do is it shifts. It shifts the horizontal asymptote. So in this case, it shifts it up 2 units. In this case, it shifts it down 2 units. So what I'm going to do is first go figure out the horizontal asymptote of this guy. So remember, my horizontal asymptote, I'm looking at number 1, says compare degree of numerator to degree of denominator. Well, in number 1, my degree of my numerator is 0. The degree of my denominator is 1. So 0 is less than 1. If I go find my case for m is less than n, it says y equals 0 is my horizontal asymptote. But this minus 2 shifts it. So y equals negative 2 is my horizontal asymptote. So which graph here has a horizontal asymptote at negative 2? And the only one that does is this one. Okay? So, boom, my answer for number 1 is B. All right, let's go try one more. I'm going to come over here and I'm going to look at 3. So, horizontal asymptotes are going to be what? My degree of my numerator is the same as my degree of my denominator. So my horizontal asymptote here is y equals 1 over 1. So I've got a couple with y equals 1. I actually only have one. It's this guy. And the other thing that's going to help me limit this is I'm going to look at my denominator. So I'm going to have a vertical asymptote at x minus 1 equals 0. So I'm going to have a vertical asymptote at x equals 1. Well, which one of these graphs has a vertical asymptote at x equals positive 1? And it's right here. There's my vertical asymptote at x equals 1. Here is my horizontal asymptote at y equals 1. Okay, so the answer to number 3 is D. So I want you to figure out the rest of these by using that process, okay? All right, let's shift to the guided notes that are inside your packet here. So I want you to keep these. These are going to help you with this, with how to sketch these things. All right, how do we sketch the graph? We are sketching. And we are going to start with the parent function. The parent function of all rationals is 1 over x, okay? He's called a hyperbola, and all hyperbolas have 2 branches, and the branches either look like this. Those are some branches, so don't sketch this in, I'm just talking. Or I can have 2 branches like this. I can rotate their spots. They kind of look like a messed up parabola, don't they? And 2 of them. So it kind of looks like a parabola, but it's not really. And it's a totally different equation, as you can see. All right, so how are we going to do this? The first thing we're going to do is I'm going to try to sketch in the horizontal asymptote. So to figure out my horizontal asymptote, let's look at the degree of my numerator. The degree of my numerator is 0. The degree of my denominator is 1. So 0 is less than 1. I'm in that case. And when m is less than n, my horizontal asymptote is y equals 0. So this is how I'd like you to do this. I want you to sketch it in, and I want you to put an HA here. So a horizontal asymptote, remember, is a boundary that I pretty much don't cross. Later on in math, you might cross them, but pretty much for us, we're not going to cross them. So my graph isn't going to cross that. The next thing I'm going to do is I'm going to move on to part 2. I'm going to factor this thing. Well, he's factored. Okay, so the next thing I'm going to do is see if I'm going to cancel anything. So he's factored. I don't have anything to cancel. So now I'm going to look for my vertical asymptotes. I have a vertical asymptote at x equals 0. I'm going to set the denominator equal to 0 and solve for x. So what do I want you to do here? I want you to sketch in your vertical asymptote, and I want you to tell me it's a VA. So what happens here is we're going to have a couple branches. Our hyperbola is either going to go like this, or it's going to go like this. Once you know one, you know where to put the other guy in. So this is how we're going to do this. Okay, it says select x values, create a sign diagram, and sketch in branches. So what I want to do is I'm going to go figure out what the sign of this is over when x is negative 5. Okay, so at x is negative 5, 1 over negative 5 is a negative number. So you know what that means? Boom, my negative branch, this is how it looks over here. Okay, let's say I didn't pick negative 5. Let's say I picked positive 5. 1 over 5 is a positive number, which means my other branch goes over here. Once you check one, though, you don't need to check the other. Okay, that's my graph. It's important to put the arrows on to say that these things go on forever and ever. It's important to make it look like a curve. It is not a line, it's a curve. Okay, so this is the simplest of case. This is the parent function. We're going to do another one. That's your second example. That's a little more in depth. Okay. So this is your example 2. We are going to sketch the graph of this. So first things first, let's talk horizontal asymptote. The degree of my numerator is 1. The degree of my denominator is 2. So I am in the case m is less than n. And if we go and look in our notes from yesterday, this means I have a horizontal asymptote at y equals 0. Okay, so I'm going to go put in my horizontal asymptote at y equals 0. And I'm going to write HA here. All right, next I'm going to factor. So this is the same as x over x minus 2 times x plus 1. I can't cancel anything out, so there are no holes. So I'm going to say none. But I do have 2 vertical asymptotes. I have a vertical asymptote at x equals 2. And I have a vertical asymptote at x equals negative 1. So I'm going to go back and put this in green just so I stay consistent. That's my horizontal asymptote. My vertical at x equals 2. So 1. So here's a vertical asymptote at x equals 2. And then I'm going to come over here and at x equals negative 1. Now, remember what I said before. We're either going to have, I'm ditching the intercepts, okay, guys? My branches are either going to be like this. If he's there, my other one's here. Or if he's here, my other one's going to be down here, and something's going to happen in between. So this graph is going to look totally bizarre. So how are we going to figure that out? Well, let's go over here, and 5 is a neutral value. It's not on my asymptote. So let's go ahead and check what happens when we use 5. Okay, so if we use 5, I want to see the value of my function. So what is 5 over 5 minus 2? Oh, I'm sorry, this is a negative 5. So negative 5. Negative 5 minus 2, that's a negative 7. Over a negative 5 plus 1, that's a negative. So I'm going to end up with a negative number over a positive number. What is a negative divided by a positive? A negative divided by a positive is a negative number. So what that means is I've got a branch down here. That's where I'm drawing him in. What that means is I've got my other branch is up here. All I did was figure out if my sign is positive or negative. If my value of my function is negative, my graph's going to live down here. If the value of my function is positive, it's going to live up here. If you want to compute this out, you can. You're going to get negative 5 over positive 35, and that's a negative number. So that's how that works out. Now the question is, how do we figure out this middle part? Now we got to go talk about the middle. The middle's going to be something like this. The middle is going to look like a cubic, and it's either going to go like that, and if he doesn't go like that, he goes the opposite of that. So what would be the opposite of that? Oh, I have to erase this. The opposite of that would be this. So we're not sure, but we can figure it out. We can figure it out. So this is the number 2. I'm going to pick the number 1, and I'm going to see at 1, is my value of my function a positive number or a negative number? So when x equals 1, I end up with 1 over 1 minus 2 times 1 plus 1. So I end up with 1 over negative 1 times 2. So this is a negative number. So I know at 1, my graph is down here somewhere negative. So I'm going to do this. And that's it. So we're going to use that sign diagram in really 2 locations. All right. I'm going to do another problem with you, and then you're going to work in class. Let's try number 8 on the back side. So go to the back of your packet. Let's look number 8 up. All right. So first things first. I've got a horizontal asymptote where when I figure out my horizontal asymptote, I'm going to take my degree of my numerator, which is 2, my degree of my denominator, which is -2. So, wow. Where does that fall? M is greater than N. 2 is greater than -2. So in that case, I have no horizontal asymptote. So go ahead and write none. Okay? Once I've got that, we're going to go through and we need to factor. So I'm going to erase this so we've got some room here. If you need to pause and rewind, go ahead and get that. I'm going to factor. So if I factor the numerator, that's what I get. If I factor the denominator, I'm going to take a -2 out of everything. And I'm going to get x squared plus x minus 6. So what happens is I'm going to further factor that. X times x plus 1, and I get a -2. Down here, don't I get an x plus 3 and an x minus 2? Yep. So I have vertical there's nothing that I can cancel out. I have no matching factors. There's no holes. So I have a vertical asymptote at x equals -3 and at x equals 2, right? I have 2 of them. So let's go put in my vertical asymptote at x equals -3 and then let's go over to 2. All right, so we're going to have a couple things going on. We are either going to be like that or like that. So let's go figure out what happens with that. Okay. So I'm going to look at this function, and if this is -3, I'm going to go out here to -5 and see what happens. So in my numerator, I get a -5 times a -4 all over -2. A -5 plus 3 is a -2. A negative, and that's a -4. So my numerator is positive, but my denominator is negative. So over here at -5, I have a negative. My answer is negative, so I'm going to do something like that. Okay? Now we have to go back, and if that's, I'm not sure that that's going to be the case over here. I'm going to go check when x is a +5. Because I'm worried about this -2. So let's go plug in the +5. Okay, so we get 5 times 6, which is a positive number, and then we get -2. But what happens when x is 5? That's a positive number, so that's 8, and that's a positive number. 5 minus 2 is 3. So I end up with a positive over a negative. So I have this situation. They're both negative. That's that part. Now we've got to go in and check in here. Okay, so let's go check in here. What happens when x is the number 1? Well, when x is 1, I have 1 times 2, and then I have a -2, and then a 4, and a, what's 1? That's a negative number, right? Because I'm using 1. Yeah. So I get a positive over a positive. So at 1, I'm up here somewhere. Now let's go check when I'm on this side. Let me go check at a -2. So at -2, I have a negative times a negative over, there's a -2, that's a +1, that's going to be a -4. So my numerator is a positive number, my denominator is a positive number. So they're both positive. So what this means is this thing must do this. Okay? So we can say wholes are none because we didn't cancel. And our domain, let's fill in, it's all real numbers except, but x cannot equal a -3 or +2. Okay? So I know that's a lot going on there. There's a lot to do this sign checking spot. So this is what I would like you to do in class. I would like you to do all the problems. The only thing that you are skipping for me, you are going to skip number 6. You're going to skip number 6 on the back side. So put a line through that. And I want you to skip number 4. So you're skipping 4 and you're skipping 6. And we just did one for you. So you only have 5 of them to graph. You have 6 matching, 5 to graph. Okay? If you're stuck, I want you to check the website for solutions. I will also email them out to you, okay? All right, this is due Tuesday. I'm going to collect this, or I'm going to check it when you guys get to class. Have a great weekend. Sleep in, see a movie, stay warm. Thank you.